Welcome back, everyone. We are going to solve another problem using custom functions in Excel using VBA. And this one is really fun. You may recall from a math class the concept of a Fibonacci number. There was an Italian mathematician named Leonardo Pisano who had a nickname of Fibonacci. And in the year 1202, he solved a puzzle regarding rabbit populations. And in doing so, he generated a sequence of numbers which came to be known as Fibonacci numbers. And so here in our list here in this text box, we have a series of numbers. So the Fibonacci number for 0 is 0, for 1 it's 1, for 2 it's 1, 3 it's 2, and so forth. And if you look closely at this, each Fibonacci number is the sum of the previous two numbers. So 34 is the sum of 13 plus 21, and 21 is the sum of 8 plus 13. And so fib of n is equal to fib of n minus 2 plus fib of n minus 1. So what we have here is a spreadsheet where we have a sequence of numbers. It starts out consecutive, but then we skip a few numbers here and there. And we want to write a Fibonacci number function so that when you give it a number, it returns the corresponding Fibonacci number. For example, if you pass it number 7, it should return a 13. If you pass it number 9, it should return a 34. And so we're going to write a custom function called fib, F-I-B, that takes a single integer n and returns the corresponding Fibonacci number as a double. And why a double? Well, we could use an integer, but sometimes those Fibonacci numbers get really large, so we'll do a double just in case. And then we're going to enter it in cells B5 through B17. And away we go. Now note that the first two Fibonacci numbers, the Fibonacci number for 0 is 0 and the Fibonacci number for 1 is 1. We're going to take advantage of that information. But let's jump right in. We're going to go over to our code, and this is the module code. Start out with a little option explicit like we normally do. We're going to say function fib n as integer, and we're going to return a double. So there are actually several ways you can solve this problem, and I'm going to cover one of those ways. It's a pretty simple method using an array. So we have to anticipate, if suppose the user passes in 17, well, in order to calculate the Fibonacci number of 17, we need to know the Fibonacci number of 16 and 15. And those numbers are dependent on the numbers before that. So somehow we have to iteratively calculate those numbers all the way up so that by the time we get to 17, we already know what the Fibonacci numbers of 15 and 16 are. And we can do that by rotating through a series of variables with a for I equals loop. But another one that's fairly simple is to use an array. And so to start off, we are going to, we're going to do something to handle the special case though. If the user asks for the Fibonacci number for 0 and 1, we don't need an array. We don't need to do anything. We can just return that right away. So we can say if n is less than or equal to 1, then fib equals n. And so we'll just handle that as a special case. And otherwise, we need to do some magic. So otherwise, we're 2 through something. And in this case, we're going to declare an array. We're going to say redem f going from 0 to n as double. And so we're going to declare this array f, which is we're going to populate that. And we already know we wouldn't be here if we weren't already at 2, so we're going to say f of 0 equals 0. In other words, the Fibonacci number of 0 is 0, and the Fibonacci number of 1 is 1. And then we're going to say dim I is integer, and for I equals 2 to n, f of I equals f of I minus 2 plus f of I minus 1, next I, and then at this point we are done. We can just say fib equals f of n, the last number in the array. And that should do it. Let's go test it, and then we'll step through it and explain it in more detail. We went through that kind of quickly, but let's make sure it's working first. So go back here and say equals fib of n, and here we go. All right, let's check our results. Looks like it's working. Fibonacci number 1 is 1, 2, let's go up to 6, should be 8, that's correct. 7 is 13, 8 is 21, and so on and so forth. So it looks like it's working correctly. Let's go back and check out our code here. In fact, let's step through this. Let's do the Fibonacci number of 8. I'm going to put a breakpoint right here. And then we'll go right here and put the cursor in the formula bar and hit enter. So n equals 8. And I'm going to do something else here. I'm going to add a watch for that array that we declared. It's going to be empty to start. Whoops. Not what I wanted to do there. I want to have this floating over to the side. Let's see, let me try that again. Cancel. All right, well, let's just leave it up there. Let's see, I got that one out of the way. So what we're going to do is we're going to step through this. So basically, if n equals 0 or 1, we're just going to return n as our Fibonacci number. There we go. That's what I wanted to see. So here's our array up here. And right now, initially, we've used the redimension statement to declare this array using a variable. And the lower index is 0 and the upper index is 8. It needs to go from 0 to 8. And we're going to start out by filling in the first two values, 0 and 1. And then we're going to loop from 2 to n. So the first time through the loop, I equals 2, and it's just going to say f of 2 is equal to f of 0 and f of 1. So it's going to fill in this number right here as the sum of the previous two numbers. And then it's going to go to the next one. N is equal to, I is equal to 3. And it's just going to be the sum of the previous two, and so on and so forth. We just keep looping through this array, populating the values, and in each case we're adding up the previous two numbers and storing that in the array. And when we're done, the value in the very last slot in the array corresponds to the Fibonacci number that we are looking for. So we can simply assign that to our function name, which is the way that we define the return value, and then we're done. And that properly fills in, returns the Fibonacci number for 8, which is 21, and we have solved the problem. So that is a nice, simple way to solve that. And again, the objective here is not necessarily on Fibonacci numbers, but how to use custom functions. And this is just another example of how you can solve some really interesting problems by writing a custom function in VBA and then deploying that in part of your formulas in Excel.